Numeric types. Numeric types can be divided into subgroups. So the first one, integer types. As you can probably guess from the slide, we have the capability to store multiple, to define multiple types depending on how big the numbers will be. So, for example, if you know that you're going to be storing maybe some sort of a ID number that you have a lot of control over, what's the range, then you can make a decision depending on uh, that knowledge and to, again, manage data. Again, the difference between medium int, let's say 3, and int 4 bytes of memory space is not huge. However, if we are talking about millions of rows, many tables, then that little difference now might amount to maybe hundreds of megabytes, if not more. So, um, big int, the largest data type, it's basically probably used for scientific purposes. Then int also it's basically a 10-digit number that you can store from negative to the positive sign. Now, if you want to go medium int, then it's going to be about 7 digits, up to 8 million. Small int goes from 32,000 plus to minus 32,000 and a little bit. And then tiny int from plus 127 to minus 128. So that's these are the range. Now, interestingly, we can also define those types as unassigned types. So what it means is that we could, for example, for the tiny int, which by default goes from minus 128 to 128, we could have an unsigned tiny int that goes from 0 to 255. So it kind of gives you more range on the plus side and cuts off the negative side, as your range. So here is the kind of summary of what we are talking about. So tiny int goes from negative number to a positive number. That's the range. If you want to store data in the 1 byte memory slot, or from 0 to 255 if you define your type as a tiny int. And as you can see, the ranges for the other numbers are also listed here. Here is now a little bit more details into the type definition. So we mentioned the unsigned definition attribute. Now there's also a zero fill. So the zero fill attribute is meant for the integers, and MySQL displays integers with basically whatever the user enters, right? So if you have an insert statement, you provide a number, let's say 100. Now there might be situations in which you would like to display the integers with the space padded with zeros. So for example, you have a number that is going to be smaller than the maximum number allowed for that type. So you can pad with zeros that space. What would be an example? Well, perhaps sometimes you see ID numbers displayed that way. So instead of going 1, 2, 3, 4, 5, you see 0, 0, 0, 1 and 0, 0, 0, 2 and so on. And then once the number gets bigger, then the padding obviously gets reduced. So zero fill is basically the padding of the number. Now you can also control the padding by specifying the number of basically the slots in the display side. So it's a little bit like in C++ you do set W. So this is basically you specify the display size here, and you use the parentheses notation, and this only affects this setting only affects the MySQL uh, display. This is not affecting the storage of the actual number. So whatever your query returns will be affected by the zero fill and number in parentheses, but do not expect that you will change the storage format. One more interesting point that I would like to make is that tiny int, when it's set to basically display format 1, gives you a way to represent a boolean type, true or false. So the bool type is basically the same type as tiny int 1. So you can store true or false, where 1 represents truth, and 0 represents the false value. So tiny int 1 is compatible with the boolean type. Now decimal types. So we have obviously numbers that have digits, in the after the decimal point. So you can use the decimal type to store those kind of numbers, and these are so-called fixed point numbers, because these numbers of the decimal type will have the m amount of decimal digits to the left, and the fixed amount of digits to the right of the dot. Right. So this is called fixed point notation, and the number of digits stored to the right of the decimal point sometimes is called a scale of the number. So the total number of digits is sometimes called the precision of that number. So kind of a little bit of terminology here. Obviously, this is a perfect type for storing prices, right? Monetary values, where you can control very tightly the number of digits before and after the storage memory storage requirement varies depending on the number of decimal digits, but it's kind of grouped. So for example, typically on MySQL databases, 9 digits will go into 4 bytes, right? So if you go over 9 digits, then you reserved another 4 bytes and so on. So this is not a situation that we've seen in strings, character types or variable types, where it's kind of like one-on-one relationship. Now, in addition to the decimal type, we have also a double and float type. So these are floating point number types, or floating type data types, which have a very similar meaning to what we have in the programming language. What is the difference between the double and the float? Well, float is considered a single precision number, which provides the so-called single precision, which boils down to 7 significant digits. And the double type is considered a double precision number, which gives you up to 15 significant digits of storage. Obviously, the double and float types are kind of considered approximate, because there may have some rounding going on, as opposed to the decimal type, which is an exact type, right? So you're never gonna run into a rounding issue. For in MySQL, for decimal and double and float types, uh, um, you have kind of also the situation where you can use uh, the unsigned attribute and zero fill attribute. So they work basically, in a similar way, um, as those attributes applied to integers. Right. So there is obviously many synonyms for those types. For example, the real number and the double precision types are considered synonyms. So sometimes, a double will be referred to as a real number, and we have, like we said, we have basically a floating point and fixed type. Floating point are those approximate numeric types. Another type, besides the numeric types, is the date and time. So here is the examples, um, and these are really closely related to your implementation of the application side of the system. And let's let's take a look at those, knowing that really the full logic besides differentiating or selecting the appropriate type would be probably the implementation cost on the application side, where there might be already a certain solution existing, or there might be already some processing libraries being used, and this selection here might be driven by the how easy or how difficult it might be to actually make the database compatible with the dates generated on the application side. So to make the long story short, at this point, we have the date type. So this is basically date information without time information. Now we have a time type, and that's what we're gonna use if we want to store the time information without the date information. Now, if we want to store both, then we have two types available. There is a date time and timestamp. So typically, timestamp would be used to kind of keep track of the transactional data, because in SQL we have a timestamp function which generates a data in a certain format. So we could keep track of when the when the row is inserted into a table, or when the update was made. So that kind of application probably is going to be mostly compatible with a timestamp type. Now the other type, the date time, is probably a type that might involve the date information coming from other sources, not necessarily from the timestamp function in MySQL, but maybe from some other applications. Now, the interesting piece of information is that the timestamp is currently subject to the Y2K38 problem. So basically, what it means is that this date type can store dates only up to the year 2038. So if your transactional system is handling something kind of involving current time, and maybe not so distant future, you are good. Now, if there's a chance that you might run over, 2038, then you have to switch to the date time format. Probably, this is an academic discussion at this point, because probably this situation will be handled with, not too in a not too distant future. So there will be, for sure, there will be updates and so on. Now, there is also another type called year, and this type enables us to store just the year. That format is limited to dates between 1901 and 2155. So there's some limitation here as well, but it gives you some functionality to store just years. Now, this notation here enables us to define the year type to be either a 2-digit or 4-digit format. So the default one is 4-digit format, and in 2-digit format, obviously, we are abbreviating, or we are truncating the first 2 digits, and in 2-digit format we can go from 1970 up to 2069, knowing that we are truncating the first 2 digits. Now, here is what you see is the type of problems that I'm obviously talking for quite a bit already about the formats of dates. And so literal value. So this is basically the left-hand side column is the data that might be coming from the application to the database somehow through the insert statement, obviously, or the update statement. So there is some latitude. For example, right, you can store the date, and you can generate the date in this format, on that format, or that. So there is some latitude, but there is also some types that might be obvious for some people, that will cause a problem, right? Like, for example, let's compare this one, right? This value here, which is probably out of range, right? Or let's compare this value here with some other values using forward slashes, maybe let's say this one. And you can see that there might be some nuances, and there is obviously some decision making to be made. There's different styles of representing dates on various systems and various countries, and that might cause problems. So that's why I'm saying that there might be some decisions to be made, in whether we go into the native date type, like some of these types, or whether we're going to go into a string type. Right, and again, for the time information, there is some types that will be accepted, but there might not be types that are accepted. So there is again similar issue here. How do we generate a valid timestamp if we want to use a database compatible date type, and if we not necessarily want to use a MySQL timestamp function that generates by default a date in a correct format, like for example here, values stored in datetime or timestamp column, which is generated by the date timestamp function.